Hi and welcome. I'm trying to learn electrical engineering, to take electrochemistry, and after we've done it, we're going to do a bit standing yoga. And if you participated with standing yoga, then it's been at your own risk. Electrochemistry. An electric current causes chemical change to take place in certain substances and mixtures. Okay, the current, so the electricity is causing the stuff to make some changes in which the current is coming in. Okay, the first steady electric current was produced by Volta in 1800. Okay, there was someone, and basically was a person doing electricity. And this person, Volta, made in 1800, was that person able to make a steady electric current. This was achieved by using a primitive type of battery. Okay, the person had a battery. And the battery, more correctly a battery of cells, is a device which converts chemical energy into electrical energy. Okay, we're having chemical energy and we're making out of it electrical energy. And that is happening with that battery. Many years later, several well-known scientists, including Sir Humphrey Davy and Michael Faraday, used electrical currents from batteries to split chemical compounds in elements. Okay, there were no other people, and they had chemical elements, and they splitted them by using the electricity out of the batteries. So electricity can be used to make changes to substances. This conversion of electrical energy into chemical energy is called electrolysis, a word meaning to split up by means of electricity. Okay, to do the process of making chemical changes, to splitting two elements, to think one stuff into two stuffs, using electricity for it, or electric current, is called electrolysis. Obviously, we are dealing here with a reversible phenomenon, an energy change which can occur in either direction according to circumstances. Okay, now we're having two elements, and by putting them together, we're getting electricity. Let's see that. Electrolysis is concerned with liquids, for the most part solutions of substances in water, but sometimes molten substances at high temperatures. Okay, electrolysis where we're having liquids, so fluid things, oftentimes some type of fluid with water, but sometimes also molten things at high temperatures. In the same way, the solid substances can be divided roughly into two classes, conductors and non-conductors. So can liquids be classified generally into conducting liquids called electrolytes and the others called non-electrolytes, which cannot conduct an electric current. Okay, we had already things like iron, I think we had it, whatever. Iron can transmit electricity quite good, wood pretty bad. And now we're saying there are some liquids which can do it good. Water, I don't think it's that good, but it can. And another liquid like whatever is even worse. A simple experiment can give some indication of a different liquid. Oh, I understand how it works. One liquid is not getting to make the current flow through it so good, and therefore they are changing and splitting. I don't really understand how it works, but I think that's how electrolysis works. A simple experiment can give some indication of the different liquids in each category. Okay, we're making an experiment and we're leading electric current through one bowl full of water and then a bowl full of something else, and we're looking what is delivering the electricity better through it. As this experiment involves using the mains electrical supply, I don't understand the word. Using the mains electricity supply, I don't understand the word mains. I don't even know what the word means. I only know main, but there's no mains. Some type of electricity supply. It is one that should only be carried out by teachers and not by pupils. Well, if I would understand that part here. As this experiment involves using the mains electrical supply, it is one which should only be carried out by a teacher and not by pupils. I think they're saying they're needing a lot of electricity or a lot of current to make that experiment, because they have to put a lot through the water or the other substance which we have there to know which is have the electricity flowing through it as good as the other one. and that is dangerous, do I want to say. Electrolytes will allow sufficient current to flow through them to cause the lamp bulb to light. Yes, if enough electricity or current comes through the water, then the bulb lamp is still burning. If you're taking something which is like stone, which it's not liquid, but it does not, what is it even called? Deliver the electricity through it is not good. You will find that solutions of acids, alkalis, and salts are electrolytes. So we're saying they are good. Okay, we can use some types of acids or alkalis or salts, whatever they now actually are, and they are delivering the electricity good. A solution of sugar in water is not an electrolyte. Neither are organic compounds such as petrol, paraffin, methylated spirits, and turpentine. Okay, we're saying sugar in water is bad to deliver electricity through it, and we're also saying that things like petrol or paraffin, because they're organic compounds, we're saying oil is basically bad. So we're saying, I would like to have an example. Acids or alkali seems to be a broader category. I'm saying water delivers electricity okay, and things like oil or petrol bad. It doesn't really matter, for example, if it's true or not. The term iron should be familiar to you from your previous studies. Some type of iron, I don't know what iron is. I know the term, but I don't really know what it is. Briefly, an iron may be said to be an atom or small group of atoms which has gained or lost one or more electrons. Oh! An iron is an atom that had got an electron more. Or lost. So, there's our atom, and it has a bunch of electrons around it, and if it loses one or gains one, it becomes an ion. I don't know where they are. An electrolyte always contains ions. Okay, a liquid such as paraffin is not an electrolyte because it consists solely of complete electrically uncharged molecules and no ions are present in it. And why? Whatever. Basically, the point we're saying is, and I think I know why, ions are letting the electricity better through it because they have an electron more or less in them. And as far as I know about chemistry, that makes it easier to react with our elements because now we're having one too much or one too little, and they are better fitting to a puzzle piece which has a hole fits better into another puzzle piece which has one thing standing out, and then they're fitting perfectly together. And the thing is basically that thing. If it has one too much or one too less, so it is an ion, the atom then can deliver the electricity better because it fits with another one together. If it has one too much with one which has one too little, it fits perfectly together. And the two combine together, then the electricity flows. I'm not completely sure, but I somehow put that together. Maybe some parts of it are correct. At this point, we must emphasize that an electrolyte must be a liquid. Solid dry sodium chloride, which is common salt, is an ionic electrovalent compound composed entirely of sodium ions, Na+, and chloride ions, Cl-, but does not conduct electricity because the ions are not free to move. The ions are locked in a solid crystal lattice. Okay, let's do it again. At this point, we must emphasize that an electrolyte must be a liquid. We're saying an electrolyte must be a liquid. But here for solid things, we had conductor and non-conductor. Okay, an electrolyte must be liquid. Solid dry sodium chloride, which is basically salt, is an ionic, and it is therefore an electrovalent compound, and it is composed entirely of sodium ions and chloride ions. So sodium chloride is composed out of sodium ions and chloride ions. So it's sodium chloride, or commonly named salt. But it does not conduct electricity because the ions are not free to move. The ions are locked in a solid crystal lattice. Salt is dry, I think that's what I want to say. And it cannot move. Liquid can flow around and therefore bring electricity from one side to the other one, and they cannot because the atoms, the sodium and the chloride atoms cannot move around. They are dry and locked into a crystal lattice, whatever form. Only when the salt is dissolved in water and the ions become free to move independently can they play a part in the conduction of the current and cause salt solution to be an electrolyte. And where we have it, sugar is not an electrolyte, and sugar in water and salt in water is. I don't know why, but basically we're saying is, I think we're saying water with salt conducts salt better if salt in water conducts current better if salt is in water. And if sugar is in it, then it's just so good. What amount of sugar makes the amount of salt again back to neutral normal level? It would be really, really interesting. It would be a nice experiment. We have to do yoga. We have 4 minutes left. But I want to read on. The word iron, in fact, means wanderer. Iron means wanderer. That must be in Greek. Whatever. I don't think we should read on and just read it. I want to read it almost desperately, but we should not read it. We should go through it, probably. They are basically saying sugar and water does not deliver water good. It is non an electrolyte, and salt and water is an electrolyte that delivers conduct good. That was electrical engineering. If you are here for electrical engineering, you can go directly to an expert of electrical engineering. If you stay and participate in this yoga, dann ist bei dir auch your feet standing together and we're breathing in and lifting the arms up. We roll the arms down. In and up. Out and down. In and up. Out the arms to the side. In and up. Out to the other side. In and up. Inch space between the feet, Nick. Out on the side. In and up. Out, sink down. In and up. Out on the other side. In and up. Out and down. In and up. Out, hands down onto the knees. Breathe in. Out the head with the back. Again in. And out and out back. Again in. And out the head. Again in. And out and out back. Again in. Out with the round back up. Backward shoulder. Breathe in with the arms up. Out on the side. In and out. Out. Go over sides down. Breathe in, come halfway up. Come high up. And out and come up. Breathe in, come up. Breathe in, reach high. Breathe out on the side. In and up. Out and down with the arms. Breathe in, come halfway up. Come high up. And out and come up. Breathe in, come up onto tiptoes. And breathe out and sink down into the chair. It can go onto the knees. Again, in and up. And out and down. In and up. Bring your arms over sides down, the feet are standing together. Breathe in, bend the right knee. Breathe out, stretch your left leg. Breathe in, change. Out, stretch right leg. In, change. Out, stretch your left leg. In, change. Out, stretch right leg. In the middle. Out and down. Breathe in, lift the right hand up. Breathe out, bend the left knee, look over the right shoulder to the right hand. In and down. Out and down. Breathe in, lift the left hand up. Breathe out, bend the right knee, look over the left shoulder to the left hand. In and down. Out and down. Make a hand with space between the feet. Shift the weight to the heels. Breathe in and get the go down. And out and up. In and down. Out and up. In and down. Out and up. Take hold of the elbows and gently rock from side to side. And hands down, feet together. Breathe in, come halfway up with a straight back. Out and down. In, halfway up, straight back. Out and down. You can bring the arms up. Hands up, and again down. The toes are pointing to the outside. Have an order left space between the feet. Breathe, toe up, breathe in. And out. Bring the chin down onto the chest. Slowly roll the spine down. Out to the ground. Take the elbows against the inside of the knees. Straighten up, breathe in. And out, tuck the pelvis in and come with the crown of the head first, slowly up. And another round, breathe in. And out, chin down onto the chest and roll slowly down. And down, elbows against the inside of the knees. Breathe in, straighten up. And out, tuck the pelvis in, come with the crown of the head first, up. hands again. Now lift the arms up. And lift out and down. In the arms up. Out, lean back with long arms. And up. Out and down. Lifting the arms up. Out and down. In the arms up. Bring your hands to touch and lower hands down to heart center. It was fast and short yoga. I thank you very much and until next time.